Okay, let's try this again. So we're going to talk about exam 3. It is next Thursday, so same rules as before. You have a 24-hour window as far as the whole exam. As soon as you start, you'll be timed for the given amount of time. I don't yet know whether there's going to be a written part. I will let you know that as soon as I do know. I hope I will know that by Monday, but if not, I should know by Tuesday at the latest. So I'll be working on the test tomorrow, and I'll be working on the test Monday. It just depends on how quickly that goes. As far as programming questions into WebAssign, sometimes that takes a while. So anyway, I don't know the format yet, but I will let you know as soon as I do. As far as the topics, we've got improper integrals, where the practice is in Unit 1. So practice sheet in Unit 1 folder. And then we've got sequences, which is a big part. So sequences, you need to be able to like guess about convergence and then find terms in a sequence and a corresponding series. You need to be able to do the big thing is show whether a sequence converges or diverges. And then if it converges, find its limit. And so, we did several techniques for that, but you've got two big homeworks are sequences 1 and sequences 2. So the homework for that, there's the intro sheet, and then sequences 1 and sequences 2. And that's all in Unit 3. So, and you should have solutions to almost all that. The intro sheet, probably not, but for the sequences 1, sequences 2, where you have the main problems, you've got the problems and then worked out solutions. And then series, which is the biggest part of the exam, also in the Unit 3 folder. So we've done geometric series. We've talked about we talked about telescoping series. We talked about the K-term test, the harmonic series. Then we did P series, comparison tests. So that's the direct and limit. And then we talked about absolute convergence. And then we talked about the alternating series test. And then today we're going to talk about the ratio test and the root test. Those are the main parts of series. So those are the biggest parts. Also, we did the integral test yesterday. And there was something else that I was going to say, but I forget. That might have been it. Okay, like I said, I'm not purposely leaving anything off, but if I'm leaving off something that is on this test, let me know. But those are the main things. Integral test is not that it's not important. It's just we kind of treat it separately from the rest of them. It was more used to prove P series, and we did it yesterday kind of after the fact. So we're going to talk about ratio root test today. But those are the main topics on the exam. Like I said, I'm not purposely leaving anything off, but like if I'm forgetting something, it's everything we've kind of covered since the last exam. There probably will not be much from old exams on there other than just you might have to know how to do an integral for the integral test or for improper integrals. But, you wouldn't expect to see any area or volume questions on the exam. So it'll all be related to sequence series or maybe improper integrals. Okay, any questions about that? Okay, and so we'll actually be done with the new material today, which means next week we will be doing review sessions at least twice during regular class. So they'll probably be just question and answer session. I'll send you an email either tomorrow or Monday about the schedule. But we could potentially have 3 review sessions Monday, Tuesday, and Wednesday. We probably won't do one at night since we'll be able to use the regular class time for review sessions. So that's it as far as the exam for now. As soon as I know more about the format, I'll definitely let you know. But let's about the ratio and the root test. So we're going to write it out. Let's get rid of this. All right. So when we talk about the ratio and the root test, so these are two different tests, but they're actually based on the same idea. And so that's one of the reasons we study them together. But the root test or ratio test, what it says is it says if the limit as k approaches infinity of the absolute value of a sub k plus 1 divided by a sub k is equal to L or infinity. And it wouldn't be negative infinity because the absolute value, but it's equal to some number L or maybe the limit's infinity. It can't be one where the limit just doesn't exist. Let's make infinity a little bit neater. All right, so equals to L or infinity. Then, and you know what, let's, okay, so then if L is, and we can get rid of this if, I guess, if L is less than 1, then the corresponding series converges absolutely. If L is equal to 1, my bad, L is greater than 1, or if it's infinity, then the series diverges. And if L equals 1, then you should use a different test. Meaning the ratio test doesn't tell you what happens. It could converge or could diverge. And in both cases, we're talking about, you know, the series, the sum from k equals something to infinity. We'll go ahead and just say 1, but it could be 0 or whatever of ak. So that's the series we're talking about. And so what you do is you evaluate this limit of ak plus 1 over ak for whatever this is, and you get a number L. If that number is smaller than 1, the series converges absolutely. If it's bigger than 1, it diverges. If it equals 1, you should not have used the ratio test. And so let's do an example, and then we'll talk about kind of, there are two other things we want to talk about. So this is, we want to see first how it works. The second thing we want to talk about is why does it work? So why is this going to tell us the correct thing about whether the series converges or diverges? And then the third thing we want to talk about is how do you know when to use this? So when would you use the ratio test instead of what we've been doing or some other test? And so right now, let's first figure out how to use it. Then we'll talk about why it works. And then we'll talk about how to know when to use it. So the first problem I actually want to do is the sum k equals 0 to infinity of, we'll do k to the 4th over 2 to the k. So if I have the sum k equals 0 to infinity of k to the 4th over 2 to the k, and the directions would just say show whether the series converges absolutely, converges conditionally, or diverges. Go ahead and write that too. So show whether the series converges absolutely, conditionally, or diverges. Okay, and so if we're going to use the ratio test, what you do is you start by saying, okay, the limit as k approaches infinity of the absolute value of a sub k plus 1 divided by a sub k. And the way we do that is we say, okay, well, a sub k plus 1 means we plug in k plus 1 for all of the k's. So we get k plus 1 to the fourth over 2 to the k plus 1. That is a sub k plus 1. And then instead of dividing, even though, I mean, clearly it says divide by ak, instead of actually writing it as divide, we multiply by the reciprocal of ak. And so we multiply by this flipped over. So times 2 to the k over k to the fourth. Does that make sense to everybody? Please ask if any of this is unclear so far. Right now, we're just trying to figure out how to do it. So once we've determined we should use the ratio test, do we understand how I'm getting this set up? Everybody good? Okay. So now we're going to try to simplify this. And when you have k plus 1 to the fourth, there's not much you can do to simplify that. You can multiply that out 4 times, but that's not very helpful. And it's also important that this doesn't like cancel with the k to the fourth, but the exponentials do cancel. And the way we can cancel those is we can split the larger exponential into the smaller exponential. So we're going to leave k plus 1 to the fourth alone. And then on the bottom, 2 to the k plus 1, we're going to rewrite as 2 to the k times 2 to the first. And we do that because now the 2 to the k's will cancel. So we're going to cancel those out. And now we will evaluate this limit. So we're going to have the limit as k approaches infinity of k plus 1 to the fourth over 2k to the fourth. And then if we think about this, you could multiply this out, but if you multiply this out, what is the biggest term going to be in the top? So like we look at the biggest thing over the biggest thing. What's the biggest thing going to be in the numerator? What do you guys think?
K to the fourth?
Yeah, it'll be k to the fourth. So we're going to get the limit as k approaches infinity of k to the fourth over 2k to the fourth, which is then 1/2. Okay, we're not done, but that's evaluating that limit. Does everybody follow how to do that? Any questions on how to do that? That was good. Okay, and so if we go back up, what we said about the ratio test is, okay, you get this limit L. Well, if it's less than 1, it converges absolutely. Bigger than 1, it diverges. If it is 1, you shouldn't use this. And so 1/2 is obviously less than 1. So then we say, so the series converges absolutely. And that's by the ratio test. So this is how it works. Any questions on what we're doing on each of those steps? Okay, so this is how you use the ratio test. The other two things that we want to be concerned with are, why does this work? And then the other thing is, okay, how do you know when to use this? And so why this works is when we're doing this, we're taking the limit of ak plus 1 divided by ak. Well, that's the next term divided by the one before it. So like this is the 100th term divided by the 99th term, or the 2001st term divided by the 2000th term. And so to get from one term to the next, eventually, when you divide each term, you get about 1/2, which means to go in the long run, to go from one term to the next, you're multiplying by 1/2 every time. What type of series do you multiply by the same thing every time in? What type of a geometric series? Yeah. So this series itself is not a geometric series, but as k goes to infinity, it's like a geometric series because you're multiplying by 1/2 every time. So in the long run, it behaves just like a geometric series. Well, then this L value is like the thing you're multiplying by. That's like the common ratio. Well, if that common ratio is less than 1, if the absolute value of that's less than 1, just like a geometric series, it diverges. If it's bigger than, I'm sorry, it converges if it's less than 1. If it's bigger than 1, it diverges just like a geometric series. On a geometric series, the breaking point is 1. So if it was 1 to the k on a geometric series, that diverges. But here, it's not that it's actually geometric. It's that its limit behaves like a geometric series. So it's not actually 1 to the k. That's why it's inconclusive. Whereas the geometric series 1 to the k would diverge. This is inconclusive because it might not actually be 1. It's just approaching 1. And so what we do know, though, is if it's less than 1, it's like in the long run, it's like 1/2 to the k. If it's bigger than 1 and you get like 2, then it's okay. It's like 2 to the k. Well, that diverges. So it behaves just like a geometric series. The problem is when it is 1, we don't know. And so then you have to go back and do something else. So the reason why it works is because it's just like a geometric series in the long run, is what we're kind of proving by proving that this ratio approaches 1/2 or whatever it is. Does that make sense to everybody? We clear? Okay, so that's the rationale for the ratio test. When to use it. So there's, just like with integrals or anything else, there's not a definite thing that says, okay, this is when you always use the ratio test, or this is when you always do integration by parts. We don't have something like that. But some guidelines are you typically have a mix of function types. So like if you go back and look at what we were talking about on videos last week, we were saying, okay, you have these ones where it's like all power functions over all power functions, or all exponential functions over all exponential functions. And every now and then we'd have something weird mixed in, but for the most part, it was those. Well, here we've got a power function k to the 4th mixed with an exponential function 2 to the k. That doesn't necessarily mean that you use the ratio test, but that's a key indicator that you might. Another thing that you look for, so you have a mix of function types, you have a lot of times exponentials with a base other than 1 or -1. So you could have -1 to the k, but the fact that you do have something else, 2 to the k, that's something that you look for. The reason you look for something like that is because that's one of the types of functions that when you evaluate this limit, this cancels out and you're left over with something that's not 1. Like if you just had this k to the 4th and k to the 4th, the limit would be 1, and that's when this test doesn't work. But if you have a leftover 2 somewhere, or if the base is 7 and you have a leftover 7 somewhere, that's when you're likely to get a limit that's not 1, which means it's likely the ratio test is going to work. Does that make sense to everybody? So, and like I said, it's not that you can't have 1 to the k or -1 to the k, you can, but those aren't as helpful in getting this to work. 2 to the k is very helpful in getting this to work because you get a leftover 2 probably. And then another thing that is almost always ratio test is if you have a factorial in the formula, then a lot of times use ratio test. So what I'm writing in red here, things to look for. To know to try the ratio test. And again, those aren't definite things that work every time. Oh, and another big one is all multiply and divide. So like not much addition subtraction, or like if it is addition subtraction, it's like in parentheses to a power. So things where this limit's going to be easy to evaluate, whereas addition subtraction, a lot of times that's not the case. Again, it's not that you can't ever have addition and subtraction. You could. It's not that you have to have a factorial. It's not that factorial always means this. These are guidelines. So normally these are things that mean, okay, let's maybe try the ratio test. All right. Any questions so far? Does that make sense? Okay, so we need to know how to use it, which we just figured out on number 1. We're going to do another example, but we need to know how to use it. We need to know when to use it. These are the guidelines, or these are some guidelines to know when to use it. And we should understand why it works. And the reason why it works is because what this is telling you is in the long run, this looks like a geometric series. So, okay, so number 2, same directions. We're going to show whether the series converges or diverges. Converges conditionally, absolutely, or not at all. So we'll go k equals 0, we'll go k equals 1, not bad. 1 to infinity, and we're going to say negative 1 to the k, 4 to the 2k minus 5 over 3k plus 7 factorial. Okay, so this has almost all of the guidelines in it. There's a mixture of function types. You've got exponentials with a factorial. You've got an exponential where the base is not 1 or negative 1. Like I said, negative 1's okay. It's just having another one is usually helpful for the limit to work out the way we want. And then you've also got a factorial, and it's all multiplication and division. So this is a key one to definitely use ratio test on. And so we look at this and say, okay, well, we're going to try the ratio test because it has all the stuff. And so we're going to say, okay, let's do the limit then as k approaches infinity of the absolute value of a sub k plus 1 divided by a sub k. And now when we do this, a sub k plus 1, let's be real careful. But when we do it, we get negative 1 to the k plus 1, 4 to the 2k minus 3 over 3k plus 10 factorial. And now we're going to multiply by the reciprocal of AK, but I want you to think about this for a minute and see if you can figure out how I got this. So don't tell me yet, but figure out how come this is what AK looks like. Why is that AK? And then, I'm sorry, AK plus 1. Why is this AK plus 1? And then AK flipped over is this. Okay, so negative 1 to the k plus 1 is pretty obvious because you put k plus 1 there. Can someone explain why that's 2k minus 3 and not 2k minus 4 or something else?
Looks like you multiplied the 1 by the 2 in front of the k.
Yeah.
And then on the, because the bottom one's minus 3 and the top one, or you add 3 to it, and then the top one you subtract 2 or add 2 to it.
Yeah, you add 2 to it, but it's because you're doing this. So you're replacing the k with k plus 1. Does everybody see what I'm doing? So then the 2 distributes. And that's where I'm getting 2k minus 3 for this power. And then same deal down here. To get 3k plus 10 factorial, I'm replacing this k with k plus 1. So I've got 3 times k plus 1 plus 7 factorial. Well, that's 3k plus 3 plus 7, which is then 3k plus 10. I guess it's all factorial, but 3k plus 10 factorial. Does that make sense? Everybody follow that? And now, okay, we're going to flip that one, flip the original to get this because we're dividing by AK. Any questions on how to get this set up? Okay, so then the algebra here is weird. So we're going to go through it because you're going to, on ratio test problems, you do a lot of this stuff. You don't always do all of this within the same problem, but what the common manipulations are with exponentials and factorials. And so when you have exponentials, you want to take the larger exponential and break it into the smaller one. So you've got negative 1 to the k plus 1 and negative 1 to the k. Well, the smaller one's negative 1 to the k, or the smaller power is k. So we're going to break this into -1 to the k times whatever's left over, which is -1 to the first. Now, it's weirder when you have addition and subtraction in the top. So you have 4 to the 2k minus 3 here, and you have 4 to the 2k minus 5 here. Well, the smaller one is 2k minus 5 because you're subtracting more there. So 2k minus 5 is smaller than 2k minus 3. So what we're going to do is break it into 4 to the 2k minus 5. So we're going to choose to make it match this smaller one, and then times whatever's left. So what would I need? 4 to what power to get back to 4 to the 2k minus 3? What do you guys think? What would I need? Squared. Yeah, because if I now add those powers, then I would get back to 2k minus 3. Does that make sense to everybody? Everybody clear why I'm breaking it up that way? Okay. And now factorials, we talked about this a little while ago, or at least I did in one of the prereq videos. I forget if we ever talked about it live. But when you have factorials, you can get the bigger one to cancel with the smaller one. And so 3k plus 10 is obviously bigger than 3k plus 7. And so you can split 3k plus 10 into 3k plus 10 factorial into 3k plus 10 times 3k plus 9, because that's one less than that, times 3k plus 8, because that's one less than that, times 3k plus 7, and then factorial. And remember, for factorials, you can basically stop wherever and just say factorial, because that just means that down. You choose to stop there because now it's going to cancel with the 3k plus 7 factorial that we've got over here. So you've got now 3k plus 7 factorial here, and then -1 to the k on the bottom, and then 4 to the 2k minus 5 on the bottom. Well, now a bunch of stuff cancels. Any questions on the algebra? Because it's weird algebra. It's not like crazy hard, but it's just not normal to do this stuff. It's stuff that you do a lot with ratio test, and we're going to be using a lot even after this exam. So you want to get used to it, but it is weird. So yeah, go ahead, James.
Can you just say again how you got that 4 squared?
Yeah. So like I know that this one's bigger because 2k minus 3, you're not subtracting as much as 2k minus 5. And so you choose to make it into the smaller one. So I picked 2k minus 5 because it's there. And then I got to think, okay, how do when I multiply these, I'm going to add powers. So what do I need to add to this to get back to what I had to begin with? And so 2k minus 5 plus 2 would get me the 2k minus 3 that I had to begin with. Does that make sense?
Yeah. Okay.
Okay. Yeah. It is weird. I know that's weird. So anybody that has another question or even the same question, feel free to ask that. Any other questions so far, guys? Okay. So we do that now because a bunch of this cancels. So like the -1 to the k is cancel, the 4 to the 2k minus 5 cancel, and 3k plus 7 factorial cancels. And now we break this down and we get, okay, the limit as k approaches infinity. Well, the top is -16, but the absolute value of that is 16. So we can make the top 16. And then the bottom is 3k plus 10, 3k plus 9, 3k plus 8. Okay, well then if we look at that, we've got all power functions basically. So the biggest thing on bottom, if you multiplied all that together, would be 27k to the third, but you're going to have 16 over infinity, which goes to 0. So the limit there is 0. And I'm fine if you can look at that and realize that it's 0, or if you want to write an extra step, you can do that too. Does everybody follow how to get 0 there? Okay, and so for the ratio test, what is significant about that is that 0 is less than 1. So this series converges absolutely. By the ratio test. Does that make sense? Any questions on that? Okay, so now if you'd gotten like 3 here, or if we got infinity, if this was flipped upside down and it was infinity, then okay, that'd be bigger than 1, and that's when it would diverge. And so you kind of go back up here, and those are the possibilities. The times you're going to get 1 are almost all of the problems we've done before today. So like if you go back and look, and they're like all power functions. Remember when you're doing the limit comparison test and you almost always get 1? The limit comparison test is not the same as this, but a lot of the same algebra applies. And on basically all of those, where it's all power functions and all exponential functions without a mix, you're basically going to get 1 every time. And so you shouldn't be using the ratio test on almost every problem. There's a few exceptions probably in there that we could have used the ratio test on, but for almost all the ones up till now, you would not have been able to use the ratio test because you would have gotten 1. All right. Any other questions so far, or any questions so far? Okay, so I want to talk about the root test. Whoops. Let's make it match just because I think it'll look better. But all right, so if the limit as k approaches infinity of the k root of the absolute value of ak is equal to L or infinity, then same conclusions. So if L is less than 1, the series converges absolutely. If L is bigger than 1 or it's infinity, the series diverges. Or if L equals 1, you shouldn't use the ratio or the root test. The root test, the idea is, okay, well, you take the k root of everything. And so let's actually do an example, and then we'll kind of talk about why it works and then when to use it. So number 3, we will do the root test on. And so let's do the sum k equals 4 to infinity of 4k plus 1 over 3k minus 7 to the 2k power. All right, so this is an example where we will use the root test. And so what we do is we start it just like the ratio test, except instead of the ratio test, we're taking the k root of the absolute value of this. So, well, that's the k root. Oops. And in this case, everything is positive, so you could drop the absolute value. Okay, well, if I take the k root of this, that's the same thing as raising it to the 1 over k. So what happens is this power gets divided by k. And so we get the limit as k goes to infinity of 4k plus 1 over 3k minus 7 to the 2, because you divide 2k divided by k when you take the k root. Does everybody follow that? Everybody good? Okay, and then there's a couple ways to think about this. I think the easiest way to think about it is within the parentheses, the limit is pretty clearly 4/3, because it's 4k over 3k, and so then you get 16 over 9 for this limit. Does everybody follow that? And you could probably drop the limit as k goes to infinity on this part if you wanted to. Just say it's equal to this. All right, and in this case, that's 16 over 9 is bigger than 1, so the series diverges by the root test. All right, any questions? Okay, so this is how the root test works. the reason it works is because what this is telling you is that in the long run, the k root of all the terms is 16/9 or close to that. And so in the long run, this series looks like 16/9 to the k because this is the k root of it. Well, 16/9 to the k is a geometric series. And so again, same idea as before, whatever you get for this limit, this L, that's like the common ratio for a geometric series when this happens. And so if it's smaller than 1, it converges. If it's bigger than 1, it diverges. If it was actually geometric and it was 1, it would diverge, but it's just the limit here. And so it's not actually geometric, which means we don't know when it is 1 because it's close to geometric, but it's not quite. And so you don't use the root test. So the reason it works, same rationale as the ratio test, that in the long run, it's a geometric series, or it's very, very close to a geometric series, so it behaves the same way. The times to use it are when it's easy to simplify the k root of something, which is not something that's normally easy to simplify. What made this one easy to simplify? Like, why was this step easy? The fact that everything was to the k. So everybody see that? So the times that you use it are if you can rewrite so you have a bunch of stuff to the k power or to a multiple of k. That's a key indicator. Another key indicator is when k is in the base and the exponent. Of the same expression. So if you have k to the k, those are key indicators of when to use the root test. So if you go back and look, that's not something that happens very often. Like you have k to the 4th, you have k in the base here, and then you have k in the exponent here, but you don't have k in the base and the exponent of the same expression. Here you do, again, up here you don't. You have 4 to the k, and then you have k, but not to a power. And then down here, you have k in the base and the exponent of the same power. So you've got this expression where k is in the base and the exponent. That is a key indicator that you're going to try to figure out a way to use the root test. You want to get it where you have everything to the k power, which this one basically already is, so it's pretty easy to do. You'll see a couple examples in the homework where you have to do a little bit of manipulation, but very little manipulation. You have to basically be able to get it so that it looks like this, so that the simplification is something we can handle. So the root test, we don't see it used a ton because this is fairly rare for that to happen. But if those things happen, that's when you're going to use the root test. So the stuff in red up here, these are things to look for to know that you should try these tests. If you work it out and you do get 1, then you can't use that test. So that doesn't mean you just give up. That means you should not have started with this test and you should go back and do something else. Every now and then that may happen, but if you pay attention to these guidelines on most of the problems, if you're interpreting these guidelines correctly, then you're going to be using it on problems where you should be using it. But that is basically it. Any questions on ratio and root test? Everybody good so far? Okay, so let's talk for a minute about next week. I don't know that I want to do 3 separate review sessions the way we normally do review sessions. And I'm genuinely asking, do you guys think it would be helpful if we did a session, like I'll be here every day, but what if we did a session on Monday where I sent everyone here a test and put you guys in like breakout rooms and let you work on the test and I could be around to answer questions? Like, is that something that would be helpful, or is that, it's up to you. You guys are the ones here coming. Is that, I will take suggested. You like that idea? Who would be interested in doing that on Monday? Like, I'd still work with you, obviously, but like what I do is I just send everybody a file with an old exam on it. Like if we were meeting in class, I'd put everybody in groups and do it. Is that, who would come to that? like I'm happy to do it. I just, okay, yeah, give me a thumbs up or yes, no in the participants tab, so I kind of have an idea. Okay, so I think that'll be enough. If we get here and absolutely no one's here, then we'll just cancel. But then what we'll do is we'll plan on Monday will be a practice test session. And so I'll find an old exam, or I'll modify slightly an old exam. And what I'll do is I'll send everybody the exam via email, probably 15 minutes before class. And so you can download that. You can print it if you want, or you can just pull it up on your screen, and I can also send it in chat. And then I'll separate you guys. It'll probably just be random into breakout rooms. So I'll put you in a breakout room with like 3 or 4 people in it. And then you guys can work the exam, and then I'll be around in the smaller groups where I can share my screen. You guys will be able to share your screen too, if that's helpful. Like you can use the whiteboard and annotate. I don't know if you've done a lot of that with Zoom. We haven't, just because attendance hasn't been required this semester, but there's some cool stuff you can do with Zoom where you can work together. It's of course, it's not as good as if we were sitting at a table and everybody working together, but it's, I think, the best we can do remotely. If you don't find that's helpful, then you certainly don't have to come, and I'll still give everybody the old exam to practice. It might be one that you already have. It's just, let me see what I can find that's helpful. So we'll plan on that Monday, and that'll be from 12:30 to 1:40, like normal for Monday. We'll say about an hour, and so that'll be Monday, and then Tuesday, Wednesday, we'll do like the regular question answer review sessions, and then I'll open those up to everybody. Mondays will be open probably just to students in my class, or if you're coming every day to my class, that's fine. You can just come on Monday, but I probably won't announce it to the other instructors. But if you're here and you're actually in somebody else's class, of course, you're welcome to come if you've been coming to my class all the time. Or if you have a friend or something and you want to bring them, I'm fine with that. I don't want to have 100 people in the thing on Monday, but whatever, whoever wants to come, that's completely fine. My guess is we'll have, about like this 20 students. So I'm hoping I'll be able to go around and help people a lot during that. So we'll try that Monday. Let's see how that goes. And then Tuesday, Wednesday, Q&A review sessions where you can ask basically whatever you want. So then remember that for homework, you don't have a lot of homework right now. Series 4, the last, is it numbers 11 to 19? I think that sounds right. 11 to 19. Double check those numbers. That's due Monday, whatever I've said in the email or on the CrowdMark thing. That's due Monday at 11:59 p.m. And of course, I could help you with that Monday as well. And then Tuesday, Wednesday will be review just during class, so we won't do one at night, but that'll be open to anyone in any section. Test is Thursday, and that will bring us up through next week. We are done with material for the exam, so go practice ratio root test. If you want to see any more examples, there's the static video from a couple semesters ago that's on there under the Unit 3 videos on the same YouTube channel. So I'm sure I did different examples because I just made these up today. So I'm sure they're similar, but different numbers. So you can see we'll be working out other ones. But that is it for today, you guys. Thanks for coming and have a good weekend.